In the previous section, we learned some derivative rules, and in this section, we're going to continue to add a few more rules. In this specific video, we're going to talk about the product rule. Now, to introduce the product rule, we're going to look at this problem. Does the derivative of the quantity x cubed times x to the fourth equal the derivative of x cubed times the derivative of x to the fourth? First, let's look at the left side. So let's start with d dx. And if I want to make this into one term, I will add the exponents to get x to the seventh. Now I can use the power rule and take the derivative of x to the seventh. So the 7 will come out front, and I'll subtract 1 from the exponent to get 7x to the sixth. Now let's look at the right-hand side. If I take the derivative of x cubed, I'm going to use the power rule, so the 3 comes out in front. I get 3x, and then I subtract 1 from the exponent, so 3 minus 1 is 2, times the derivative of x to the fourth. I'm going to use the power rule again. 4 comes out in front, times x, then I'm going to subtract 1 from the exponent. I get 3. Since these are all being multiplied, I can move some of the factors around. So 3 times 4, that'll be 12. Then I have x squared and x to the third. I can just add those exponents and get x to the fifth. So the big question is, how do I handle something like this equation here on the left? The derivative of x cubed times x to the fourth. Now, for this problem, it's really easy to combine the x's into one term and find the derivative. But what do we do if it's something more complicated? We need another rule, and the rule we're going to use is called the product rule. So if h of x equals f of x times g of x, then the derivative, h prime of x, is going to be the first function f of x times the derivative of the second function plus the second function times the derivative of the first function. This is the product rule. Okay, a couple notes about the product rule is, first, some products can be simplified to avoid using the product rule. We saw that up here on the left-hand side of this expression. We were able to combine these terms because they both have the same base and then find the derivative. But if the directions say explicitly that you must use the product rule, then you'll have to use the product rule. Also, the formula for the product rule will most likely not be given to you, so this is a good one to memorize. One other note, and that is some functions need to be rewritten so they appear as a product of two functions. That might occur with something that has a square root, which will need to be changed to something with a power to the 1/2. Or, since we don't know the quotient rule, if I have something like natural log of x over x squared, well, we can't use the product rule, but I can rewrite this as natural log of x times x to the -2. Now I can use the product. Let's do this example. We have the function of x equals 3x squared times the quantity 4x minus 8. I think to make this easier, I'm going to change this to h of x. Then we could call this f of x, and this one here will be g of x. So let's list everything out. F of x is going to be 3x squared. So f prime of x, using the power rule, the 2 comes out in front, multiplies by 3 to get 6x, and then I subtract 1 from the exponent, which just leaves x to the power of 1. And g of x is going to be that second factor of 4x minus 8. G prime of x, I have a 1 in this exponent. The 1 comes out in front, multiplies by 4, so that leaves that as 4. Then I subtract 1 from this exponent, so that gives me x to the 0, which is just 1. Then the derivative of negative 8 is just 0. So now I have all the pieces, so I can use my product rule. H prime of x is going to be the first function, the f of x, 3x squared, times the derivative of the second, which is 4, plus the second function, which is 4x minus 8, times the derivative of the first function. Now I'm going to multiply these two together, so the 4 times 3, that'll be 12 out in front. Then on the second term here, I'm going to distribute the 6x to 4x and to the minus 8. So I have 12x squared plus 24x squared minus 48x. And then I'll combine some like terms to get 36x squared minus 48. Now, as you're looking at this, you might see that we can do it another way. So let's erase all this. We can distribute this 3x squared and multiply by 4x, and then also multiply by minus 8. So that will get me 12x cubed minus 24x squared. Now, as it stands right now, I've just rewritten the equation. I haven't taken the derivative. So now I'll take the derivative using the power rule. This 3 will come out in front and multiply by the 12 to get 36x. Then I'll subtract 1 from the exponent to get 2. This 2 here will come out in front and multiply by 24 to get 48. X, I subtract 1 from the exponent, so the power would be 1. That's a hallmark of calculus. There's lots of different ways to do things. If the problem specifically says that you have to use the product rule, then you need to follow that. If it doesn't say, you're welcome to solve it through any of the rules that we've used that are appropriate. Now you will have the opportunity to do some practice problems on the bottom of this page and the next page. We'll see you in the next video for the quotient rule.